Good morning, everybody, and welcome to this final webinar in the three-part series entitled Progressing Partnerships, hosted by the Secretariat of a Global Resource Alliance with support of the New Zealand Ministry of Primary Industries. This session is entitled Demonstrating Impact, and it will present an example of the practical methods that can be used for compiling livestock greenhouse gas emissions inventories, mainly based on an IPCC Tier 2 approach. And it will showcase good examples and practical examples from the development of a Tier 2 greenhouse gas emissions inventory for the dairy industry in Kenya. This webinar will mainly draw from a recent publication that was entitled Livestock Activity Data Guidance that was published in conjunction with the FAO and the GRA. And this was to improve understanding of the steps that is involved in compiling a greenhouse gas inventory on a tier 2 level. I'll be your chair. My name is Linda Latoy, and I'm from the Department of Animal Science at the University of Pretoria in South Africa. Just a few housekeeping rules before we get going with the webinar. The recording of the session will be made available for future viewing via the GRA website. Today we will have two main presentations, and I will allow questions and answering sessions after each presentation. So we look forward to your participation in posting questions. Remember, there's a upvote icon under your bar at the bottom of your screen. Please use that upvote icon if you see a question that is interesting. Maybe it's the same question that you would like to ask, would you like to have answered. So please, we rely on you to upvote those questions so we know which ones we need to give priority to. If your questions do not get asked during the session, don't despair. All the questions asked during this webinar will be collated, and it will be answered after the webinar, and questions and answers will be posted on the GRA website. So thank you for joining us today. We'll do our best from our side to make this smooth and a successful webinar, and we look forward to all the participants' participation and active participation in terms of questions and conversations. That being said, I think we can now move on to our first presenter, Andreas Wilkes. I think most of you know Andreas. Andreas has had training in anthropology and economics and has worked in natural resource management in Asia and in Africa for more than 20 years with a focus on rangeland management and livestock. Since 2008, much of Andreas's work is focused on climate change mitigation, including the development of greenhouse gas quantification methodologies for mitigation projects, and supporting improvements in national greenhouse gas inventories and MRV systems. He's been an associate expert with Unique Forestry and Land Use since 2011. And he was one of the lead authors in the Livestock Activity Data Guidance manuscript. So thank you very much, Andreas. We look forward to your presentation entitled Practical Methods for Compiling Livestock Greenhouse Gas Inventories Using the Tier 2 Approach. Thanks, Andreas.
Thank you very much, Linda. Can you just confirm the sound is clear?
Yes, I can hear you.
Okay, good. Then I'll go ahead. So thanks very much. So I'm going to give a brief summary of some work that we've done together with the State Department for Livestock in Kenya. And it should really be my colleague Benjamin Kibor who goes first, as he will be giving a more high-level overview of the importance of the inventory work in Kenya. I want to talk about some of the more practical, technical issues to explain how we've gone about developing this Tier 2 inventory for dairy cattle in Kenya. Just trying to work out how to get my screen to move forward. There we are. So the first I want to talk about is just some overview about key issues in livestock greenhouse gas inventories, particularly explaining why the Tier 2 approach is relevant and useful. Explain some of the methods that we used in the Kenya situation, and then summarize a few key points. In terms of Tier 2, you can see the relevance really from countries' commitments in their nationally determined contributions. So in the first round of NDCs, there were 92 countries that included livestock emissions, either specifically mentioning some livestock mitigation actions or generally including it in the scope of agriculture, forestry, and other land use. But only 21 of those countries have a Tier 2 approach that is able to reflect the effects of change in livestock management or productivity on greenhouse gas emissions. So there's a big gap between the ambition and the ability of GHG inventories to track change in line with that ambition. So the progression from Tier 1 to Tier 2 is really important to help fill that gap. Just for those who are not familiar, many of you will be familiar, and apologies if you've heard me presenting this before. The Tier 1 approach differs from the Tier 2 approach in these ways. So the Tier 1 approach, the emissions are the number of animals multiplied by an emission factor, so the emissions per animal. The numbers of animals are only general categories, so beef cattle, dairy cattle, without a breakdown between, say, cows, heifers, steers, calves, or other subcategories. And the emission factor is fixed per head per year. It's the same number for each continental region, which is really useful. So this is not a criticism of the IPCC approach. Compared to nothing, it's an excellent approach. The issue is, though, that if the emission factor doesn't change over time, then it can't reflect the change in productivity or the response in the sector to mitigation or livestock development policies. So that's where the Tier 2 approach comes in. So the Tier 2 approach, the emissions are the number of animals multiplied by gross energy intake per animal, multiplied by methane emissions per unit of energy intake. So in terms of implementing the Tier 2 approach, you need a more detailed classification of animals. For example, mature male and female, growing animals, and young, or even more detailed if the statistics exist in the country. And then also, we can estimate the gross energy intake per animal using animal performance, data on animal performance and management, such as milk yield, live weight gain, and so on. So if we're able to track these changes, for example, the change in milk yield, which was the main focus in the case I'm going to talk about in Kenya, then we can tell as the sector develops, how are the emissions in the sector developing. So here's some examples of what we did in the Kenya case for dairy. And I think Benjamin will explain in more detail why we selected dairy, or why they selected dairy as the starting point for Tier 2. But so what we did was to compile a Tier 2 GHG inventory going back to 1995, which is the base year for Kenya's national inventory. And this shows the result for enteric fermentation, shows that the Tier 2 approach is slightly higher than the Tier 1 approach. The trend is basically the same, but you can also notice in the last 10 years or so, the trend between Tier 1 and Tier 2 are beginning to diverge. So this shows the advantage of the Tier 2 approach in capturing change in productivity in the sector. Overall, enteric fermentation was about 85% of the livestock emissions that we estimated. So that would be the focus, for example, for future mitigation measures. So going into the more technical detail, this was really an exercise in how do you make a Tier 2 inventory with all the data needs that Tier 2 has when there is limited official statistics. Take the example of the population data. So the Ministry of Agriculture, from its administrative data, it has a total population for each of the 47 or so counties in Kenya. But there's no data on the production systems. For example, the zero grazing stall-fed animals or the purely grass-fed animals or the systems that are a mixture of the two. And there's no official data on the herd structure. So in this case, we used the total population as a consistent long-term data time series, and then used expert judgment to allocate the cattle, the dairy cattle in each county to one production system, depending on which production system is judged to be dominant in that county. And the expert judgment came from staff at the State Department for Livestock, who for many years have been working on these issues. And for the herd structure, we pulled all the available data from scientific literature on herd structure in each production system. So as an example, in the Kenya case, we defined 3 production systems. The intensive system is counties where dairy cattle are mostly raised in stall feeding. The semi-intensive counties are where the mix of stall feeding and grazing is the most common situation. And the extensive counties are defined as ones where grazing is the dominant feeding system. So with population data for each county, we were then able to estimate a time series for how many cattle or what proportion of the total population was in each different feeding system. Now this matters because gross animal performance and feed types, feed digestibility, it differs significantly between these main production systems. So that's the reason why we took this approach to defining production systems. For the herd structure, we used literature values. And as I'll explain here, the literature values are different from the values used in the official statistics produced by the Ministry of Agriculture. So the Ministry of Agriculture, like in many countries, they have a number of technical coefficients to estimate things like total national milk production. In Kenya, they assume that 55% of the cattle population is mature or adult dairy cows, and that they have an average lactation of a yield of about 1,800 liters per year. Instead of using those standard coefficients, which have not changed since the 1990s, we used the literature values, including we managed to find one study where a repeat survey had been done at several points throughout the early the 2000s. And we used that to then estimate the herd structure in the different production systems. So for example, in the intensive system, we come up with an estimate that cows are about 43% of the total herd, and in the semi-intensive system, about 35% of the total herd, which is much lower than the 55% assumed by the ministry. So in this case, our inventory would estimate a much lower total milk yield for the whole country compared to the official statistics in, for example, the agricultural GDP estimates. But since our estimate is based on the available literature rather than simple assumption, we thought it's better to go with this estimate. We also had a lot of gap filling to do in terms of animal performance. So for live weight and milk yield, for example, live weight is the main determinant of net energy for maintenance. And milk yield is one of the key variables that the ministry is interested to track from a policy perspective. But there were no data sets on, or long-term data sets on either of these parameters. So again, we turned to the literature. In the intensive region, we were able to find some relatively good quality studies estimating the live weight and the milk yield of different breeds. And in the semi-intensive region, again, one study that estimated live weight of different breeds and one the milk yield of different breeds. So we ended up using dairy breed as a proxy for live weight and milk yield. Give an example, in the intensive system, we had 3 studies that estimated the live weight of different dairy cattle breeds. Luckily, they were spaced out at about 10-year intervals. And so from this, we were able to calculate a weighted average live weight. If you look at the figures here, increasing from 356 kilograms for adult cows in the late 90s to about 366, that's about 0.5% increase per year. When we then went back to dairy experts to cross-check, is this plausible? They thought that's actually a plausible estimate of the trend over time. So because we're using dairy breed as a proxy, it's not fully accurate. It's not the ideal kind of method that we would use. But in the situation where there's no official data set, it turned out to be a practical and relatively reliable method to use, and certainly provides a basis for then future data collection to provide more accurate data. We did the same for milk yield by calculating a weighted average milk yield on the basis of breeds. And so in the figure that you can see here, the assumption by the State Department for livestock of milk yield of just below 5 liters per day, it turns out to be lower than what we estimate using the weighted average version. And our weighted average method also comes up with a trend, which again, the experts thought is plausible, given that many dairy farmers have been investing very heavily in improved feeding, improved breeding, animal health, and so on. It makes sense that there has been a gradual increase in the milk yield over the recent decades. So we were quite aware that a lot of the data sources we used they're coming from different studies with different sampling methods, different measurement methods. So we found that uncertainty analysis was a very important aspect of compiling the inventory, because it really enabled us to say, having got together an initial inventory, going forward, where do we need to focus our efforts in order to continually improve the inventory? So from this, you can see, for example, that the factors that have the biggest impact on uncertainty are in fact activity data. So the proportion of cows in the semi-intensive system, then the proportion of animals and the proportions of cows in the semi-intensive system, and then going down to item number 4, the proportion of animals in the intensive system. These are some of the really key driving variables. So we know future improvements don't necessarily focus just on the animal performance data, actually improving the activity data and improving the estimate of how many cattle are in which production system is definitely a focus for future work. If you look at some of the other variables here, feed digestibility and live weight and weight gain also come up as a very influential variables. So we know going forward, we need to focus on finding better ways to get more accurate but also representative data on feed diet composition and feed digestibility, as well as live weight and weight gain. So this exercise, whilst we were able to come up with an inventory, it comes up with an uncertainty range that is not humongous. It's probably below the uncertainty range estimated by the IPCC and definitely more accurate than the Tier 1 approach. More importantly, we are now in a better position to see where do we need to focus future data collection in order to continually improve the inventory over time. And I hope Benjamin will talk a bit about some of the plans and options for inventory improvement that we're now considering. So just a few key points to summarize. I mean, the first starting point was really a lot of discussion together with the State Department for Livestock and other stakeholders in the dairy sector to identify what are the functions that the inventory needs to have. And certainly one of the key focuses that came out of that, the inventory needs to be able to track the change in milk yield from dairy cattle. This was something linked to the dairy NAMA that the State Department for Livestock has proposed. So being able to track milk yield in the inventory would help link the inventory with MRV of specific mitigation actions in the sector. Second thing, and again, Benjamin will talk in more detail, but institutional coordination was a real key issue. Between government agencies, a critical link, well, two, I think in particular, one was with the National Statistics Office, and the other was with the Ministry of Environment, which is responsible for compiling the overall inventory. And a second point was to engage a lot of the stakeholders in the sector in order to be able to enable data sharing. There's a lot of data in the sector by research institutes, NGOs, donor projects, private sector. The question is how to draw on this for the inventory and how to engage them going forward in regular data sharing. The other lesson was that we knew from the start we would not be able to make a perfect inventory. So from the very beginning, we were trying to plan how can we do this inventory to enable continuous improvement over time. And I think the key factor is to find a structure for the inventory in terms of production systems, geographic regions, and animal categories. That if this is well suited to the nature of the sector and the nature of available data, then as we get better data over time, we can continually improve the data without having to totally redesign the whole inventory. So that's a third lesson. And the fourth lesson, really building the capacities of the inventory agencies and the key stakeholders is key. We did, to some extent, I think, achieve that. Hopefully Benjamin can talk more about this during compilation of the inventory. And we are now, in the next few weeks, having a follow-up training where Benjamin and his colleagues will be updating the inventory using the more recent data for 2018 and 2019. So this building the capacity, it happens over time as the inventory process proceeds. So it's good to plan for that from the beginning, not thinking that just compiling an inventory and the job is then done. So that's from my perspective. Benjamin Kibor, who has been involved in this through the whole process, will follow with a better overview from the Kenyan government perspective. But if you have any questions at this stage, I'd be happy to try and answer them. Just to mention, a lot of the methods that we used in compiling the inventory are described in this publication that Linda referred to, the Livestock Activity Data Guidance. Many countries that we interact with think there's a perception that Tier 2 is not possible because there's a lot of data missing. One of the focuses of this guidance is on assessing the availability and quality of data and providing guidance on data gap filling methods. A lot of it was drawing on these experiences in Kenya. So please do refer to that if you're facing those kind of issues. And then a lot of the case studies mentioned in that activity data guidance are also available on this website, agmrv.org. So Linda, have you been following the questions in the Q&A session?
Thank you very much, Andreas. Yeah, we've got two questions posted. I'll start with the first one. It's from an anonymous attendee. And the question is, Andreas, could you please expand on the approach used for the uncertainty analysis? Was it based on expert opinion mainly, or the range of plausible variability for each input variable?
A mixture. So for the activity data, because the administrative data, the cattle populations reported to the ministry do not come with any standard error. It's just the total population per county per year. What we did was, because Benjamin had been involved actually in the livestock census back in 2009. So he did some analysis to compare the difference between the livestock census value for 2009 and the administrative statistics reported in 2009 before they adjusted the two time series to be consistent. And we found, so from that, we estimated a possible range, margin of error of the administrative statistics. For a lot of the other parameters, such as live weight, feed digestibility, and so on, we estimated the range of uncertainty based on the standard deviation, or the pooled standard deviation from all the literature sources that we drew on. So we tried for these parameters as much as possible to use only data sources that reported standard deviations or standard errors so that we could estimate an uncertainty value. For a number of the other parameters in the IPCC model, the coefficient for activity, the coefficient for pregnancy, and so on and so forth, we referred to previous uncertainty analysis done for developed country inventories, where we looked at what margin of error did they estimate when they did uncertainty analysis, and we applied either the same or a slightly increased value depending on whether we thought the situation in Kenya was comparable or not. So it came from a range of different sources. Now looking back at an uncertainty range of plus or minus 12 to 14%, possibly if we go back to our uncertainty analysis, we would revise that, because 12 to 14% possibly seems relatively low. But that was the approach that we adopted.
No, thanks very much. I also think that it differs between your commercial and your smallholder systems quite a lot. The second question, there's two more and they're very similar, so I'm gonna combine them. The one is from Akin Adeshinwa, and his question is, how can African countries be assisted to generate primary data as against secondary data? And the other question by Deborah Knox is, are the production systems and data you identified similar enough that they could be shared with others in the region? So can we have a regional sort of data suppository that can be used across regions in, let's say, sub-Saharan Africa?
Well, I think that's a very interesting question, and I know that GRA is looking into this, working together with FANARPAN, and actually Linda yourself are involved. I can imagine some situations in which countries have a similar enough range of production systems. For example, many countries in Southern Africa have, broadly speaking, a communal cattle system, a commercial beef ranching system, and so on and so forth. And there may be enough similarity between them that if you use all of the data available in the region to generate emission factors for each production system, this could actually help countries avoid the need to develop them independently. However, one of the key questions is how are population data represented in the national statistics systems of each country? Because if you want a consistent time series, one of the most likely sources of data is the administrative data coming from the country. And so ideally, you would want your inventory to be aligned with those national data sources. And this may be where there are then differences between countries. So for example, dairy in Kenya, very much dominated by a smallholder sector, whereas say in Ethiopia, dairy is very much dominated by urban, peri-urban sectors. So in Ethiopia, they may have a different categorization. So it's definitely worth looking into and exploring whether it will be a simple solution or not, I don't know. And coming back to Akim's question, I think one of the really key areas that, say, the greenhouse gas inventory community needs to engage is all the initiatives about agricultural statistics for Africa, which are ongoing, led by FAO, other UN agencies, together with the African Development Bank and so on. There really needs, inventory work can really benefit from strengthened national agricultural statistics systems. So that's the other area to look into.
Okay. Okay, thank you very much, Andreas. We'll come back to some of the other questions that have been posted. I think we can now move on to Benjamin's presentation. Benjamin Kibor is from Kenya. I think a lot of you know him as well, and his colleague Robin Mbae from the Ministry of Agriculture. Both Benjamin and Robin have played central roles in Kenya's improvement of their livestock inventories, as well as planning and implementation of interventions to address different impacts of climate change on the agricultural sector within Kenya. So thank you very much, Benjamin. We appreciate you sparing the time to present your recent work to us. And we look forward to your presentation entitled Experiences from the Development of a Tier 2 Greenhouse Gas Emissions Inventory for the Dairy Sector in Kenya. Thanks, Rob.
Thank you, Linda. Good afternoon, morning, or whatever time, wherever you are. Welcome to this presentation. As said by Linda, I'm sharing experiences from the development of Tier 2 greenhouse gas emission inventory for the dairy sector in Kenya. And as been said, my name is Benjamin Kibor. My colleague, Robin Mbae, we are in the State Department for Livestock of the Ministry of Agriculture, Livestock and Fisheries. As a way of introduction, I would say the dairy sector in Kenya is single largest agricultural sector. We had to go for Tier 2. It's so significant in our country. About 14% of product. Dairy cattle are raised by smallholders, which is about over 7%. Area with the smallholder dairy farmers. The subsector has the potential to provide adequate supplies of agricultural products to meet domestic food and nutrition needs, and generate surplus for export. The dairy cattle population has been increasing continuously in recent decades from 3.25 million in 1995 to almost 4.6 million in 2017. There's an upward increase in numbers, but productivity is not so high. And as you are aware, livestock, especially the ruminants, contribute to greenhouse. Kenya, being a signatory of UNFCCC, has designed and implemented climate smart policies and strategies. Like we have climate smart agriculture strategy, and we have also climate smart agriculture implementation framework signed by the Minister of Agriculture, Agriculture, Livestock, Fisheries, and Cooperatives. And also, as per the Paris Agreement, countries showed their commitment in signing actions they would undertake based on their NDC. And this is where Kenya committed to reduce emissions by 30% in various sectors, including agriculture and livestock being part of agriculture, and being part of the main contributor of greenhouse gases is key in this achieving our targets. And this calls for accuracy and transparency in reporting, reduction in emission intensity that result from improvement of agricultural production systems. And first mentioned about dairy number, it's designed to monitor progress in dairy production and its emission intensity. And as per this obligation, therefore, the State Department of Livestock undertook to move from Tier 1 to Tier 2 greenhouse gas inventory of the dairy cattle. And Tier 2 is more accurate as it relies on country-specific activity data. And just to share some illustrations of the dairy farming system in Kenya, we have like 3 production systems. We have zero grazing. If you look at photos, it shows zero grazing system in Kenya by smallholders. There is the first one and the second one. There are different structures. We use different materials depending on the capacity of the farmer. As for the smallholder who have 1 to 3 dairy cattle. And then we have on the lower left, we have the extensive where animals are grazed. The main feeding system is grazing. And then we have on the lower right, the semi-intensive one where cattle are grazed and fed in stalls during part of their feeding program. During the inventory, there was some structure and setup, institutional setup, which were established to carry out the exercise. And it was by the Ministry of Agriculture, Livestock, Fisheries, with support of Forestry. This is where Andreas came and Global Research Alliance. We also had the New Zealand government coming in strongly. We had the CGR research program on climate change, agriculture and forest, and food security, CCAFs. So thereafter, the State Department made some consultations with stakeholders and established a team of experts in animal science. We refer them to as the core team, animal science, with animal science background, climate change, statistics, to carry out the inventory of the dairy cattle in Kenya. And this is the team. If you look at the photos, that was the team that sat and agreed on how to go about it. And the members were drawn from various state agencies in government. We had the State Department of Livestock. We had also the Kenya Agriculture and Livestock Research Organization, Egerton University, which is our training, National Environment Management Authority, NEMA, Kenyan National Bureau of Statistics, our institution is responsible for censuses and surveys, Kenya Forest Service, Climate Change Directorate, responsible for the national reporting to UNFCCC, the Kemia Institute, the National Livestock Research Institute, and Unique Forestry and Land Use. These were the team that deliberated so much on how to move forward with it. As reported by Andreas, that we needed data from various government departments and institutions. And during that period, in New Zealand, to expose how inventories are country partners, and for this it was New Zealand. You can see from the photo, this is how they measure their methane using respiratory chambers, so that they could get their country-specific emission factors. And this is where Kenya should put effort to having their own improved emission factors. And the inventory followed the IPCC Tier 2 methodology, using model of IPCC 2006 volume 4, and equation is indicated there, and the sources, GHG sources were enteric fermentation, manure management, direct nitrous emission from soils, dung and urine deposit on pasture, indirect nitrous emissions from managed soils, and indirect nitrous emissions from manure management. These are the GHG sources, and we were using those guidelines indicated by Andreas to arrive at the estimations. And the data sources that inform the development of the daily greenhouse gas inventory were from county annual reports, census. We had 2009 that's where livestock was. We also have records, farms, and then sample surveys. There are research, as Andreas said, agencies and institutions, reports and documents like CALRO, which is our agricultural research institution, and also ILRI, which does a lot of research in livestock in Kenya and other regions of the world. So we use country-specific activity data at the 15 categories, subcategories, 5 from the livestock subcategories. We had dairy cows, we had heifers, we had adult males, growing males, male and female calves, as per those 8 categories. So those are the animal categories. That's the dairy that were used, and the 3 production systems. As I mentioned, we had intensive, semi-intensive, and extensive. And the activity data were dairy cattle population by subcategory.
Sorry, Robin, can you maybe help there with Benjamin's sound? Are you close by?
Yes, can you hear me?
Yes, we can hear you, Robin.
Oh, okay. Then I'll take over.
It seems like you'll have to do the relay now and take over from Benjamin, unfortunately for Benjamin. If you can assist, maybe, Robin. Sorry, man.
Yeah, I think he's in a different area. Personally, I'm in the office. If you hear me, then I think I'll just complete the presentation with the.
Thank you very much.
The last slide on the implication of the new estimates for livestock emissions. So then what we realized is whatever figures we have been using, particularly in the reporting, in our national communications, the emissions are lower for Tier 2 than they were in the Tier 1 that we are using. Of course, because of using our activity data, but then more improvement is required. So the lessons learned, of course, this has been the discussion all over globally, that every country may need to start from somewhere. and of course use all the expertise that they have in the country to ensure that they take off in terms of trying to see how we can move from tier 1 to tier 2. But then research and development of up to date is very important. We are lucky that we have IRRI, which is an international organization, has given us a lot of data. They are carrying out also a lot of research. And so we are able to get some data on this, and I think this helped us a lot. But then also, Benjamin had a chance to go to New Zealand for some training on how to collect data and also how to measure emissions. I think that's an added advantage that GRI supported him. And therefore, it's very important for states or countries to learn from other countries, because we are not the same in terms of level and capacity. So from the word go, then, as he has mentioned, it's very important to involve stakeholders within a country and they work as a team. And that's how we started, by consolidating all the parties or stakeholders that are involved in livestock production and involved in research, involved also in policy, involved in data, to ensure that we're able to consolidate whatever we have as a country. So then, because we have different types of governments, we have the lower government, we call county governments, 47 counties, but this time we didn't go into all the counties to get some data or categorization, because some of them don't have the dairy cattle. So the cooperation between, in terms of getting reports, in terms of discussing, in terms of getting ownership and correct information, we had to work together with the other counties. Then continuity of the expertise. Once you have formed a core team, it was really very important that we continue discussing up to date until we got the final report. Yes, that should have been last slide, until we came up with that product.
Okay. Okay, thank you very much. I see there Andreas has posted the link for everybody to your report. So I'm sure that a bunch of people will go and look at the report. Thank you, Andreas. I'm sure that they can also contact either yourself or Benjamin, and then you can send the report through.
Yeah, sure.
Yes, thank you. I don't know, I haven't received any specific questions related to the Kenyan scenario. Andreas, maybe you or Benjamin can take this one again. Deborah's question popped up again. And all the production systems and data you identified similar enough that they could be shared amongst with others in the region. I know you touched on the different dairy production systems between Ethiopia and I've got other country now. Sorry, but what about diet digestibility data within a region? Very often, you know, across borders, your rangeland types doesn't differ that much. Similar soil types, similar rainfall. And looking at sub-Saharan Africa activity data, there's very little reliable data in terms of diet quality available. So do you think there might be a possibility to share across regions? Andreas?
I think certainly for grazing-based systems, as you mentioned, that no country has a really huge database on that can be used to estimate feed digestibility of naturally grazed forage. There may be differences when it comes to, say, dairy, where in store feeding systems, the crops and feeds available may differ. It's an interesting thing to look into. In any case, the estimated feed digestibility between different countries may be relatively similar, and the difference may be lower than the uncertainty associated with any one estimate. So as a first place to start, I think it would not be a terrible idea. So it might be okay to start by looking at regionals, sort of the data available within the region. rather than insisting that it has to be country specific.
Yeah, no, I agree. I think there is data available. We just need someone to go through all the manuscripts and
Yeah.
dissertations and theses that's been stuck in libraries collecting dust.
Yeah,
if we can get scientific information out there.
There's a database maintained by ILRI. I can't remember the exact name, but it's called something like Sub-Saharan Africa Feed Database or something like that. It includes a lot of data on the chemical composition of a large number of different forages and feeds. What it doesn't give, though, is the diet composition. So that's probably where a new multi-country literature review might be able to add something to actually estimate diet composition. For beef cattle, that probably is less of an issue. Certainly for dairy, it's probably a major need.
Yeah. No, I agree. Let me just go through the questions again and see if there's anything else that popped up. This question is for Benjamin from Harry Campbell Ross. Benjamin, using the experience compiling the Tier 2 inventory for dairy, will any of the lessons transfer to compiling the Tier 2 or Tier 3 for Kena's beef herd? So will you be able to transfer your lessons from a dairy towards compiling a Tier 2 a beef herd inventory? Or Robin, maybe? I don't know if Benjamin's audio has been sorted out yet. Robin, I think you're still muted. Thank you.
Yes, it is really possible to use the Tier 2 approach for other livestock like beef. But the unfortunate thing is that the data that is available at the moment may not be adequate really to give a very good report. But nevertheless, as I mentioned earlier, there is always a starting point. And we have been even working on this with ILRI to see what kind of data is available for that. To me, I think it is possible. It's possible. We have to start from somewhere, but definitely the data that we have, due to varied production systems and recording, may be a challenge. But I think we are thinking towards that, to expand it to other livestock breeds and see what kind of report we get in terms of emissions and compare it with what we have been using and Tier 1. Thank you.
Now, I know that there's been a recent project at ILRI one of our students looking at the feed basket of smallholder farmers over a 2 or 3 year period, looking at natural rangeland and actually the supplemented beef quality. So I think, and that's almost ready to be published. I think that will also improve activity data in terms of diet quality by quite a huge margin. Okay, thank you very much, Andreas and Robin and Benjamin. We are almost running out of time. I'd like to thank everybody for participating in this final webinar in the Progressing Partnership series. We will be posting updates on the GRA website about the webinar series, as well as a complete record of all questions that was asked and the answers by the specialists and experts. And the links to the recordings will also be posted on the GRA website by the Secretariat. So please, if there's any suggestions or any ideas for future series and content, please contact the GRA Secretariat. And if there's issues in your specific country that you think the GRA might be able to assist, please let them know. So from my side and from the side of the GRA, we'd like to thank you for your participation, and we hope to see you again. I would just like to then hand over to Akim Wape from the GRA to give a few final key thoughts on the series as a whole, up to date. Thank you, Akim.
Thank you, Lind and Thanks everyone for attending this session. I just wish to thank all the participants for their discussion and feedback during the three-part webinar series. Our discussions have highlighted the relevance and roles of the GRA, the importance of international research cooperation, and the practical challenges and experiences in developing Tier 2 GHG inventories. The webinar series has also demonstrated the importance and utility of international collaboration in overcoming global challenges, which is precisely what the GRA and its partners aim to facilitate. After 3 panel sessions, over 11 excellent presenters, and more time zones than we can count, we have discussed what works, what doesn't work, and what we are still all learning. All the sessions, including the one that we are just having now, will be available on the GRA website, and the documentations, like what has been shared by Andreas and our colleagues, Benjamin and Robin from Kenya, all of it will be made available through our website. Just a few thoughts or key lessons from the webinars. I think the first thing that we have learned is that opportunities for research and international collaboration exist. However, in many countries, especially in Africa, engagement of national experts and institutions in international agriculture, GHG specific efforts or networks is still very low. Successful engagement in agriculture GHG research will require us to have strategic thinking and coordination among national experts. We need to be more proactive to find out what is happening in our regions and how we could effectively contribute. In this regard, in-country leadership will be vital to all research that will be, or that will underpin GHG inventories, MRVs, including NDC implementation. Secondly, I think the webinars have demonstrated that there's a clear need for capacity development. We need to continue supporting peer learning and knowledge sharing of key topics on agriculture GHG emissions based on demand-driven interests and needs, with a focus on strengthening evidence of the triple aims of enhanced livelihoods, food and nutrition security, and reduced GHG emissions. Lastly, I just want to say that within the GRA, we are working to bring about an international research community that has undergone transformational change from one that is ineffective and short-term to one that is national, multidisciplinary, networked, and collaborative. We are committed to continue working with all national and regional actors and working together on the challenges and opportunities that we have identified, especially capacity building and awareness raising in this area. So thank you everyone who have attended this series, and please note that we are always open and happy to hear from you. We are happy to learn what is happening in your countries and how we could just effectively engage for the common good. We hope to remain in contact with you and help you connect effectively and participate in science networks, such as the GRA research networks that we discussed in the previous webinars. Thank you very much. We'll look forward to hearing from you again. Thank you.